For question 22, HKDSE 22, we are given a right angle triangle that is 90 degrees at angle ABC, and we were told that ABED is a cyclic quadrilateral. Now, if you know what a cyclic quadrilateral property is, that you would add the opposite pair of angles to become 180. So in that case, that's telling us the opposite side is also 90 degrees. That's how it's going to be added up to 180. Okay, and then we would then now put in the values. So AB is 660, AD is 572, and then BE is 275. Okay, so since these sides are given, automatically what you would be trying to do is to introduce a new line at AE. Okay, and then you're going to do the Pythagoras theorem so that you can find AE. So AE would just be the square root of the two values added together, squared. And you'll find out that the answer is 715. And then you do the Pythagoras theorem again. Now this time is for the ED. And it's basically the longer side squared, subtract the one of the shorter side squared. Then you get an answer, which is 429. So it's 429. And so after this, we would then be thinking of, oh, we need to find the length of CD here over here. So this is a right angle triangle, but unfortunately we don't know two sides of it. So we cannot use Pythagoras theorem. We have to use some of the angles instead. So to find angles, we would be then going back to these two triangles. You can use whatever you want. You can use sine, cosine, or tangent because we know every single side. So it's even it's opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. You can do whatever you want. Okay, so but basically is we will be finding the angle BAE and also the angle EAD. So both of these angles need to be found. Okay, so let's name them alpha and beta. So once you've found them, then if you go back to look at the big triangle, we know the adjacent side, and we are asked to find CD, which is part of the hypotenuse. So we'll be basically using cosine of this whole angle. Looking at the big triangle, we will be able to find the whole hypotenuse, and then you can just take away this 572 from the answer to get your solution. So let's use sine for the alpha. So if you use sine, it's basically 275 over the hypotenuse 715, and you find out the angle alpha is actually 22.6198. Okay, we normally take a few more digits, and then for the other angles, for the beta, we can use sine as well again. So sine in this case would be 429 over the hypotenuse 715, and that would give you the answer for beta, which is 36.8698. Okay, so once that's done, as I said, we're going to use the cosine for that angle alpha and beta together, which would give us the adjacent side 660 over the hypotenuse AC. So basically AC is 660 divided by cosine of those two angles added together, and you'll find out that AC is very, very, very close to 1300, because you're gonna get 1299.9 something, and that's gonna be the final step. So to find CD, that's just 1300 minus 572, and that's your option 728C.